Today's session is Linearization in Fiery XF and Fiery proServer. It is my pleasure to introduce our speakers for today. Carrie Maloney, Product Marketing Manager for Fiery Wide Format, and John Nate, Educational Architect and Trainer for Fiery Wide Format. And with that, it is my pleasure to hand off to you, Carrie, to take it away.
Thank you, Yael. So before we start, I'd just like to mention that today's session was originally advertised to also include profiling. Due to the detailed nature of the linearization section, we decided to split the topics and hold an additional session in November on profiling and optimization. And we'll give you full details of this new session at the end of today's session. So today is now fully focused on linearization in Fiery proServer and Fiery XF. Good linearizations really are the foundation of great ICC color profiles. And great ICC color profiles deliver the most accurate color matches regardless of your chosen printers, inks, and substrates. This session guides you through the linearization process and best practices and demonstrates that creating custom color files for all your printer, ink, and substrate combinations can be a reality with Fiery proServer and Fiery XF, delighting all your customers equally. Before we begin, we'd like to gather some information on our audience today, so we'll take a quick poll. You should now see 2 questions on your screen. You can select all that apply for question number 2, and I'll give you a moment to complete these. Okay, so thank you all for completing the poll. We will be sharing the results during today's session. And I'll now hand you over to John for linearization in Fiery proServer and Fiery XF.
All right, well, thanks everyone for joining us today. At the end of this webinar, what our goal is that you're going to be able to understand, first of all, the importance of color calibration. As Carrie said, it really is the basis of getting accurate color and getting good ICC profiles, is that you have the foundation of a good color calibration available to use to build the ICC profiles, which we're going to cover in the next session. In addition, we hope that you will be able to understand the different types of drivers that we have available in Fiery XF and Fiery proServer. I'll get into the details of that in just a bit, but we want you to be able to understand what they are and how to select the best driver for your particular output device and the type of material you're printing on. And finally, we want you to understand how you go about creating a custom calibration file. The calibration files that you can download or install off of the installation DVD that we supply with our systems are built on the devices that we have in our lab. Well, your device may be a little or a lot different than the one we have. Maybe it's newer, maybe it's older. You might have different media that you're using, slightly different media, maybe a different brand that has different characteristics. So when you create a custom calibration file, it takes all of this into consideration. Your machine, your ink, your substrates. Well, to begin with, we want to look at what we have available for you as really the tool. And no matter what version of Fiery XF you have or Fiery proServer you have, we provide you a built-in capability to build the calibration file. We call this a linearization file, okay? The button is to create a base linearization file, and we're going to see this live in the Fiery XF interface in just a little bit. Here is the basic color tools option interface, and here is what it looks like if you've added the color profiler option. You'll see in both cases, the very top, create base linearization. That's the button that allows you to build this calibration file. Well, what is linearization? What is calibration? Why is this important? Well, linearization is our term for it at EFI, and it does mean calibration of the system. It doesn't matter whether you have a large VUTEk inkjet printer or a small little desktop inkjet printer. The fundamental concepts of what you need to accomplish when you build a calibration file or a linearization file are the same. First, per channel ink limits. Now, if we take a look at 4 gradations one of each of the primary colors. We'll just take those as an example. Your output device may have additional colors available, but we're just going to concentrate on CMYK for a moment. Let's imagine that we're dealing with an aqueous inkjet printer, a printer from companies such as Epson or Canon or HP that use a water-based inkjet ink. Well, in this example, anything past 92% comes out wet on cyan. Anything past 81% of black comes out wet. Well, we don't want our output to come out wet. If this was a UV inkjet printer, perhaps anything past 89% in magenta comes out with no additional saturation. Maybe past 96% of yellow, no saturation. Well, in that situation, all we're doing is wasting ink. I'm not gaining anything by using 95% magenta. So the per channel ink limit idea is to limit ink where it's doing harm, images are coming out wet, or it's not doing us any good and it's just costing us money. Per channel ink limits in this case above 89% magenta, above 96% yellow. So that is the per channel limits. Next up is per channel linearity. In per channel linearity, we want to make sure that we have a nice even gradation from 0 to 100% of each of those primary colors at the point that we limit them. This is a nonlinear device. From 0 to 75%, boy, there's very gradual, hardly any gradation. From 75 to 100, it's a very, very rapid change. In the second example, from 0 to 25 is a very rapid change, and from 25 to 100, there's hardly any change. It would be very, very difficult to color manage a device that is that nonlinear. What we want is a nice even gradation, 0 to 25 to 50 to 75 to 100, a nice even gradation. So that is the second step in building a linearization or a calibration file, is per channel linearity. Next is total ink limit. Let's take a look at our UV printer, for example, and let's say that anything beyond 340%, it doesn't get any darker. Okay, there's no additional density. If any of you that understand the world of LAB color space, the L-star channel, which is basically the overall density, we're seeing that at 350%, the L-star value did not drop. Okay, so there's no point adding any more ink. All we're doing is wasting money. 340% then would be our total ink limit for this device. Now, on our aqueous device, we may find that, hey, 330% comes out wet. 320% comes out dry. Okay? There again, we want to limit our ink then to 320% to make sure that our images come out dry. Our fourth and final step is an acceptable gray balance. Now, it's not going to be perfect gray balance, but it's going to be close enough that the ICC profile can take it the rest of the way and give us nice neutral grays. Now, this is a very poor gray balance. We start kind of neutral, then we go into magenta, then back into neutral, then into green, then back into neutral. That's making our ICC profile do a lot of additional work, which we don't want. This is a good, matter of fact, this is a great gray balance. It's neutral through the entire tonal range. So those are the four steps. We want a per channel ink limit, a per channel linearity, total ink limit, and an acceptable gray balance. Now we're going to move over after we talk to drivers in the interface and see how we actually accomplish this. If you have any questions during our session today, please use the question and answer window and post your questions, and hopefully we'll have time at the end to answer any and all of your questions. But first, let's take a look at the poll results. Carrie, do we have the poll results?
We do, John. They should be on screen now.
All right. So, well, the majority of you are building custom calibration files, so that's good. Some of you are not. So hopefully you will be inspired by today's presentation to grab the bull by the horns and build your own custom calibration file and increase that color quality an additional amount on your output device. And, well, kind of a pretty even balance of the output devices we use, weighted a little more towards the ES2000. That would also be the i1 Pro 2 We add these together, and that's probably the more popular device, not a surprise. But we do have some Barbary users and some of the automated system users. So good information. Thank you very much. Now let's continue on, and we're going to start by talking about the drivers. Okay, the driver is the piece of software that really is the bridge between FireXF and Fire proServer and your output device. Okay, it's what kind of takes the data and drives it into the inkjet heads. Now, not all printers support all drivers. We have different types of drivers available. We designate them as CT, HT, and RGB. Okay, CT, which stands for contone, HT stands for halftone, and that doesn't mean halftone or contone prints. It's just a kind of a designation that the printer manufacturers have used to define how the driver actually operates. A little more on that later. And then RGB would be sending RGB data to the inkjet heads. Now, what drivers we have are dependent upon the manufacturer. Manufacturers supply us with what is called the SDK, the Software Development Kit. And in there are the hooks, the links between our software and the inkjet heads. And these are used to build the drivers. So we try to make whatever drivers the manufacturer supplies us the information within the Software Development Kit. If available, we recommend that you use the CT driver. It will be the default in your mind if it is available. It's not available for all printers. So what does the CT driver have going for it? Well, first of all, simplified linearization. Okay? The linearization process is very nice, very straightforward. I like to tell people that in order to do a linearization or a calibration with FireXF or proServer, you have to be able to answer two questions. One is, what do you want to name the file? And two, is your media coming out wet or dry? Everything else is pretty easy. The linearization with the CT driver is pretty much the easiest. Media selection, however, is very important. Okay? It's key to getting good results is to select the proper media when you're using the CT driver. On the first setup panel, you get to select from a drop-down list various types of media. With the CT driver, it's important which one you select. We're going to get into details on that when we see the interface. Okay? You do have control over the black channel. Okay? And this is especially important in building the ICC profile. The black channel you have complete control over, and the black channel construction goes quite a ways to helping you save ink. So very important. We're going to cover all those black controls in the next session in a few weeks. You do not have control over the light inks, nor do you have control over the light ink to normal ink transition. That's where light ink starts to feather off and normal ink starts to come in. Now, some people would say, well, this is the downside of using the CT driver. However, you might look at it as a plus, as a benefit. If you don't have control over this, well, it's also nothing you have to worry about. If you want to take control over the light inks and the transitions, you have to know what you're doing. Okay? We're going to look at what controls you have when we look at the HT driver after we explore the CT driver. But just because you have the option of making modifications, well, doesn't mean that is necessarily a benefit unless you know how to utilize it. Relinearization is possible. I want to caution you, our relinearization in one of the prior sessions, and we'll have links to the other sessions on what we mail out to you, I do cover what happens in linearization, and linearization is not recalibration within FireXF. Relinearization just gets back to that second step, making sure that we have nice linear output. Okay? Optimization is often what's used for getting the color accuracy back. You can use either of these tools with the CT driver. Some people, especially on the production side, hey, the relinearization is really all they need. Others, especially on the proofing side, tend to go towards the optimization routine. But either are available with the CT driver. We create 4 channels with the CT driver: cyan, magenta, yellow, black. However, do not assume that you will not use any light inks or any additional inks when you use the CT driver. That is not correct. I have an Epson 7900 that I'm going to be using as the basis of the examples here when we look at the CT and HT drivers in a bit. And it has light inks and it has orange and green. With the CT driver, they will all be used. However, it's up to the Epson software to determine when I send it the 4-channel file where to use all those additional inks. With a Canon, where to use the red, green, blue. With an HP, where to bring in the red and the blue ink. So we still will use all of the inks. So don't think that, well, no, I bought this nice printer with all these additional inks, and I want to be able to use them. With the CT driver, you will. The screening, which is the laying down of the dots, the little dithering pattern, that is the manufacturer's responsibility. So Canon or HP or Muto or Mamaki, the manufacturer determines how they're going to lay down the dots. Okay. Now, back to the second item here, media selection is important. Our idea behind building a calibration file is you want to start with the most ink possible. In building the linearization file, the calibration file, we will cut back on the per channel and the total ink. But we want to give it enough room to work. We want to be able to get as much gamut out of our output device as possible. And that means we have to make the correct media selection. Before we take a look at the interface, here is the list for you. For the CT drivers available for the Epson, we recommend premium, and I'm using semi-matte here as an example, but really you could use premium gloss, premium semi-gloss photo paper. We used to recommend Epson proofing paper white semi-matte. However, we noticed that if you select a media from the drop-down list that does not include the word proofing, we're actually getting a little larger gamut. So any of you that have used Epson proofing paper white semi-matte in the past, and our early testing showed that gave us the most gamut, we're now recommending switching to one of the premium photo papers. For an HP printer, you want to select the Instant Dry HP ID Photo Gloss, Instant Dry Photo Gloss. That'll give you the most ink. For Canon printers, if you want to use the gloss black ink, then you select Special 5 from the drop-down list. If you're using matte black ink, you want to use Special 10. Okay? So we're going to take a look now in the FireEXF interface and see how this all works. I've got my FireEXF, or Fire proServer, will look the same, interface launched. A couple of key points before we actually start looking at the calibration process. When you install and first start your system, the linearization workflow, the output side is turned off, and the input side of the linearization device is turned off. It's disabled. It's a little red square. Imagine that's a little red stop sign. That means files, and all files coming from the color linearization tool, travel through this path, will get stopped right here and won't print. It's a very common call to support. People will launch the Color Tools program, go into, say, I want to create a base linearization, hit print, nothing happens. Hit print, nothing happens. Call support. So the key is you want to click each of these once, left click, to turn them on. Now I've got a green path all the way through from start to finish. Now my files will print. The second problem we run into is people then say, okay, I want to calibrate. So the little Color Tools icon up here, it looks like a little colored pie chart. They click that to launch, and it says you must set up a valid linearization device before you can start the tool. And some people are confused. Well, what does that mean? I have the linearization device selected here, and this is the default. There is no printer selected. Here's an area where people can get themselves into a little trouble, and that is with licensing. Most of you will likely have a license for one printer, and unless you select exactly the correct printer with the correct connectivity, usually IP address or maybe USB connectivity, XF is going to see that as needing a second license. The best way to ensure that you configure the linearization device correctly is to take, if you already have configured an output device for your printer. So here I have the CT driver. Notice the little CT at the end for my Epson 7900 with my proper connectivity. If I right-click on that and select Linearize, it will automatically copy this information and paste it into the linearization device, and I won't mess up my licensing. By the way, before I do that, let me click on this drop-down, and you can see here we've got CT, HT, RGB. Sometimes we don't have anything. Sometimes we only have CT and HT. So as I said, what we have available is dependent upon the manufacturer. But we're going to start by looking at the CT driver. I'm going to right-click and select Linearized Device. It says the settings of the selected printer will overwrite the current configuration in the linearization device. I click Yes, and if I click on linearization device, you'll see it has been copied and pasted into my linearization device. Now, don't worry about, on the linearization device, which media you have selected. Under media size, you just have to make sure that the size is large enough to contain the targets. On special, the only thing you'd really have to worry about is making sure that a dryer is turned on if you want to use it. We do recommend waiting probably 2 to 3 minutes on most inkjet printers before you start measuring a target, so you might want to add that in right here. If you're using a built-in measurement device from Canon, HP, or Epson, you want to make sure that the settings for that measurement device are correct. Okay? But the main thing is you don't have to worry about what media you have selected. We're going to overwrite all of these settings when we build the calibration file. So here is the interface for building the linearization file. What happened here, I'm going to cancel this for a moment, is in the background our normal color tools window opened up and launched, and this top button was automatically clicked because I selected linearized device. All right, starting at the top, you select your particular device. Under settings, you can select the settings for that device. That usually means the illuminant mode, the M mode, M0, M1, M2. If you're unclear as to what those are, if you take a look at our Fundamentals of Color Management webinar from a while back, and again, you'll receive the link to that, I explain what that means. If you're doing printing or producing output that is intended to match one of the newer specifications, such as FOGR 51, FOGR 52, or the 2013 SWAP or Grackle, you're likely going to want to set M1. Okay? We have two buttons here, Proof and Photo Production. By the way, if I have a built-in measurement device, I could select to have linearization done automatically, and if I have the color profiling option added, the profiling can also be done automatically. And you can basically check those two boxes, fill in the blanks here, hit Next, and go get some coffee for a while and come back and everything is finished. Okay? But I want to take a look at these two buttons, Proof versus Photo Production. Keep those in the back of your head for just a moment. Okay? When we look at one of the advanced panels after one of the first measurements, that is where these really come into play. Okay? Next, we have linearization name. The default is generate from settings. I recommend actually turning that off and putting in a custom name. And the custom name I recommend you place there is the same custom name I recommend you put in here. Now, on this drop-down list are many, many different media. I don't recommend you actually select one of these media because these media also exist as names in existing calibration sets from our website or from the DVD, which means if you select one of those and don't do anything else, well, you might wind up having two media sets that are the same, one you built and one EFI built. If you do select one off the list, please add your initials to the end or maybe the date, something to designate it as custom. I'm going to go and load an existing calibration set so we can see how this all plays out. Okay? So for the settings, I've got the ES1000. I've got my custom name here. I've got my custom name for the linearization file. This is the name of the file on the hard drive. This is the name that appears on the drop-down list right here under Media Name on the Media tab for the output device. Next, we've got resolution, and there are two of them with the CT driver. You have a separate resolution for ripping and a separate resolution for printing. Okay? And you can select any of the combination that's available to you. For proofing, we're usually down around the 600 or 720 DPI, depending upon the brand of printer you have. Fine artists might even go all the way up to 2880 by 1440. Okay? Purely your choice. Print direction, as long as your heads are aligned, there's no reason not to do bidirectional for CT printing. Okay? Unidirectional, we recommend only if your heads are not aligned that well, and, well, actually my recommendation, if your heads aren't aligned that well, go align them first. And that's kind of a key. You do want to make sure your inkjet printer is printing as good as you can possibly get it at this point. You don't want to build a calibration file with half the inkjet ports on the cyan blocked. Okay? So you want to make sure maintenance on the printer is all done, all set up. And again, I do recommend you make sure that your calibration is done. We have run into some problems where people will go in, well, I'm going to print unidirectional, so they only go in and do the unidirectional calibration. Please refer to the owner's manual for your printer and do all of the head alignments that are required in the correct order. Okay, that's important. Halftoning. This is that dithering pattern, the screening pattern, and you notice only one available. It's Epson's in this case. Remember back to the previous slide, I said that it's the manufacturer's responsibility for the dots. Color mode, well, I've got a CMYK. Remember, however, XF will use all of the inks, but it's the manufacturer's driver that's going to determine where to use light ink and normal ink. The advanced button here is grayed out. This is not going to be grayed out in a bit when we look at the HT driver. Okay, I go to next. XF does a little calibration, builds the calibration, or builds the first file. You click print, and then you would click measure, and when you're done measuring, you get the green check mark. Okay, now let's take a look at the advanced button here. This is a plot of the actual measurement of those cyan, magenta, yellow, and black ramps that we printed. And an algorithm in XF has determined where to set the per channel ink limits, 95, 99, 96, 99. And what it's looking for is it's looking to make sure that we're getting as much gamut out of the device as possible. Okay? We've got a little bit of hook here on the cyan and the magenta. And the magenta said it's just going to cut back a little bit. Black, it's cutting back a little bit more on the cyan and the yellow. How does it determine where to cut back? Well, this is where that proof versus photo production also comes into play. What it's doing is it's trying to align these dots, the hue. If this goes in a different direction around the circle, we're changing the hue of the color. And it tries to make sure the hue is limited as close as possible to the hue of the primary colors of the reference profile. Up here we have a reference profile, and it says it's optional. It's optional for you. If you don't select one, XF is going to use ISO coded automatically in the background. I'm going to go in and select my Grackle profile, and you can see it's trying to align the limits with the corners. Okay, that's where we get these limits. I'm going to switch to a newsprint profile. I'll grab this newspaper profile. And you'll see we have different limits, okay? Because of where the limits are on the hue, we've come up with different limits for the ink on our inkjet printer. If you're doing proofing, XF assumes you're looking for low delta E values. And the best way to get low delta E values is try to make sure the primary colors on your inkjet printer are as close as possible to the colors of those inks on, say, your printing press. If you selected proof or photo production, then it's all about gamut. XF is going to try to give you the biggest gamut possible. So that's where this all comes into play. There's a link between the ink limits and whether you select photo or proof or photo production. Okay? Once we have those inks set, our per channels are now finished. We go to next. And this looks like the same target. We're on the linearization step now. But in fact, this ink limit, this cyan patch, which was 100% of the capability of the ink on that first panel, is now limited to that 95%. Okay? Actually, I just want to go back to settings here for one moment. I just realized I should have shown you one additional thing. And that is this drop-down, the ink. I can select my matte ink here if it's available on my inkjet printer, or the gloss ink. But this is the step where I said you want to make sure you don't select the wrong media. If you select the wrong media here, you may over-limit your per channel and total inks because the manufacturer builds in per channel and total ink limits here. You'll notice on that second step, we didn't limit the ink that much. Okay, we pretty much kept it at the same, almost close to 100%. This is going to be different when we take a look at the HT driver next. Okay, so now that we have our per channel limits, and now we print this target for the individual inks for the linearization step, we can look at the advanced after it's printed and measured, and you're going to see a curve here. Don't bother with this curve. I've done a lot of experimenting trying to improve the gray balance. The curves you see here are curves that we're going to add to the linear status. Linear means a nice even gradation. But our printing isn't expected to be linear. It's expected to have a little more weight in the midtones. And XF and Fiery proServer will automatically add a little bump to the midtones. Different amount for different printers. We've done some experimenting. What we're trying to do is match the characteristics of what we see of traditional printing coming off a printing press. We expect dot gain on press. In the early days of direct-to-plate systems, a lot of people would boast, I run linear plates, which meant their stuff didn't look good because we expected dot gain. Dot gain is not a bad thing. It's just something that happens to exist on press. And all of our separations take that into account. If you do a separation to swap or grackle or iso-coated or Fogra 51, we expect a certain amount of dot gain to happen. If we now run a linear curve on our inkjet printer, we're going to lose a little of that additional weight in the midtones. It's not going to look as good, okay? So you will normally see a curve here. Because I'm playing make-believe, we actually don't see that curve shown up here. I played around with it to try to get a better gray balance. Waste of time. Don't bother, okay? So you can pretty much ignore the advanced step there. We then go to next, and now we're looking at the total ink limit. You print this target. You want to be next to the printer when this comes out. You want to make sure that it doesn't come out wet, okay? If it comes out wet, it is going to fall face down, because that's our version, the graphic arts version of the peanut butter sandwich. Peanut butter sandwich always falls sticky side down. Well, inkjet prints always fall wet side down, especially if you happen to have your printer on carpet. It's going to land face side down. So make sure you grab this when it comes off. This is much more of an issue on the HT driver because there's not that built-in pre-ink limits into the HT drivers. But if it comes out wet, lower this value a little bit here. Notice it says 389%. This is the combination of the per channel ink limits. We limited the per channel ink limits to 99, 95, 97, 90. Add those up, and there is our 389%. That's why this doesn't start at 400. The only way this would start at 400 is if we looked at the advanced panel on the per channel ink limit, and they were all still at 100. Okay? So if this comes out wet, lower this a little bit, print it again. You want to sneak up on it. If you say, well, it came out a little wet at 389, I'll go to 300. It came out dry. Yes, but you also possibly destroyed your shadows, your D-max. You might have grayed out shadows. Not going to look good. So again, sneak up on it. It will come up after you measure it with a result. This is an ideal result. It measured and calculated 370%. That meant the per channel ink limit total was too high and we could pull back a little bit. That's good. If it comes up the same, well, you may want to investigate, did you limit the per channels a little too much? Again, you're free to move those per channel lines anywhere you want, but unless you know what you're doing, we recommend you just kind of look and see where they fall. There's a visual target that prints with this target on the printout, and it's a visual set of columns. You look at a column and determine if that's where you want to limit the ink, and it will show you, again, a calculation. This calculation is based on the columns. There's going to be a thin line through each of the squares on that visual target, and you want to make sure that those thin lines don't fill in. Where you see that they're nice and crisp and nothing's coming out wet, then you would select that column, for instance, maybe 27, and okay, the result is 350. Or you could just plug in a number. If gosh, you've used this media on this type of printer every week for the last 2 years, and it always comes up as 389. Well, you could plug in 389 there. This is the one target you don't have to print. Okay, kind of do recommend you do because, hey, maybe something changed on your printer or maybe the manufacturer changed the coding on the paper. Okay. Once you select the total ink limit, then you're on to the next step, and this is really called the quality control target. Okay. At this point, the calibration portion is finished. You've done the per channel, the total, the linearization, and the pretty good gray balance. Okay. You're going to print this, and whatever you measure here, these values, the LAB values, what color each of these squares, is going to be recorded and saved in the header of the calibration file, the EPL file, the linearization file. Those are the targets that are used for relinearization later if you choose to do that step. Clicking Next, you can change the media name here. This is your last chance to change what shows up on this drop-down list. It shows you a summary, and you could compare what you just measured on that quality control target in the profile inspector. You can compare it to one of the standard ICC profiles. You could load something else, but it'll give you an idea of how the gamut of your output device compares to the gamut of what you're trying to hit. How good are you going to be at getting all those process colors and spot colors on the output. Okay. If you have the profiling software installed, the Color Profiler suite, you could make sure this is checked, and when we hit Save and Finish, we save the file, would automatically launch the Color Profiler option. Again, we'll look at that in our next session. All right. So if we take a look now at our next driver, and that is the EFI wide format, you'll see it's the same. Our EFI wide format, the 1625, for example, is the same as our CT drivers from our other manufacturer friends, and everything is the same concept. Screening, well, kind of the same from the manufacturer. Well, we're the manufacturer, so we control the screening. So you're going to find no difference between calibrating, building a calibration file for the EFI wide format machines as any of the CT drivers. Let's move on to the HT. The HT, well, it's a little more complex linearization. Media selection is not important. No matter what media you select, it will always use the most amount of ink to start with. Okay? You still have control over the black channel, but here's the key. You now have control over the light inks and that transition. Okay? And because you have that control, again, you have to know what you're doing in order to use it. Relinearization is possible. Optimization is possible. We're now sending more than 4 channels, so it's going to take a little longer to rip your files and a little longer to transfer them to your output device. And now, EFI, we are controlling the dithering pattern. Okay, let's take a look at that. I'm going to take my HT driver that I have set up. Okay, notice there's my HT driver, and I'm going to say I want to linearize that device. Again, it overrides the CT settings that are in the linearization device, automatically launches color tools, automatically clicks that first button to bring us into the linearization portion. Now the top portion here is the same giving it the name, same what ink am I going to use. Here's the media name. This is not important. Again, it's going to control some mechanical issues, some platen gap, maybe vacuum media advance, but it's not going to affect color as far as ink usage is concerned. Let me load my HT file here, and we'll take a look. So again, I recommend the same name for the media is the same name as it will appear on the hard drive. Now, resolution, you only have one resolution. The same rip and print resolution will be used when you select one of the options. Okay? In the CT driver, they were separate. In the HT, they're combined. Print mode, I've got super versus normal. Normal is a little faster, but super will give you a little better dot pattern. Bidirectional, half toning, it's hours. If you have a choice between SE1 and SE2, SE1 tends to be a little slower but a higher quality, a little smoother output. SE2 is a little faster. Now here on color mode, I can select the option to use the orange and green, or I could select to not use orange and green. This is a case where if I don't select the orange and green, it will not use the ink. I have complete control over the inks with the HT driver. Okay? If I go into advanced, I can actually control how much light ink is at the solid areas. Right now, 70% of light ink will be added to the 100% normal ink at my solids. And I can bring that down. I can bring that down all the way down to 0 if I want. Okay? Or just leave it at the default. This is where you can control ink, especially on problematic media, clear mylar, newsprint, for example, media that just can't absorb that much ink. Okay? If I only relied on per channel ink limits and couldn't control the lighting, it would pull down both of these, both the normal and the lightings together, and I would lose more gamut. Here I can pull down the lighting separately and try to retain more gamut on my output device. Okay, we click Next. We would print, and notice I've got orange and green because I'm doing the process where I'm including orange and green inks. If I go into advanced here, well, a little bit different. Now notice this big hook on cyan, and we're limiting cyan to 59%. Well, where did that come from? That is because there is no per channel ink limit in the HT drivers. Epson limited the ink down to this area on the CT driver, so I only had to limit it a little more. Now you notice these dots. These dots correspond to these sliders. I can move these dots anywhere I want. I can limit the ink anywhere I would like to. But again, keep in mind, you really need to know what you're doing. Just don't, well, I think I'll use 75% for pretty much no reason at all. Your reasons might be experience. It might be that you see that your cyan is still over-inking a little bit. Okay? The thick blue area, or the blue area here, corresponds to this thick area. And if you keep the dots within those blue areas and stay away from the skinny areas, XF will be able to do a halfway decent gray balance. So we do recommend you keep the sliders within these areas no matter which driver you're using. Orange and green, you'll see the entire range is thick. That's because orange and green traditionally are not used for gray balance areas. Gray balance are traditionally made up of black with just a little bit of cyan, magenta, or yellow to make sure that the hue looks correct. Okay, so that's an important step. We go next. And again, this is now this looks like a much bigger target, but that's because we have to take control over the lightings also, so we need to accurately measure the lighting. So this is a bigger target. And if I go into advanced, here's our dot gain curve. Again, you can leave that alone, but here is an additional area where we control where does normal ink start. You'll notice here, normal ink starts at 28%. So anything below 28% is light ink only. I can raise that. I can lower that. What happens? If I raise it, I'm moving dark dots of ink farther down on the tonal scale. So if you're taking a close look at highlights and quarter tones, and you say, my quarter tones, I still see those dark dots of ink. I'd like to move those a little farther. Then you can move that normal ink farther in the tonal scale. Bring it down. You'll start normal inks earlier, which means you're saving money. Okay? Normal ink, you'll use less normal ink to get the same density as a larger amount of light ink. Eventually, we could actually cut that down completely and say, I'm not using any normal ink or any light ink now, only normal ink. So that would lower your cost the most, but again, you're going to start to get those dark dots in your highlights. Now, if you're printing billboards and it's going to be, a half a mile off of the highway and you're traveling at 100 kilometers an hour, well, who's going to see little dots in the highlights? So again, you have to take a lot of this into consideration when you decide how to set these options. Okay, the next step then is the same, the per channel ink limit, the quality control step no different than what we saw with the CT driver. Okay. Now let's take a look at the RGB driver. The RGB driver is really pretty much the simplest driver we have. It's very simple linearization. Media selection still is important. We don't have control over the black channel, lightings, transitions. We can't relinearize. We can optimize, but it would optimize to the CMYK space. So be a little cautious there. You're only making a 3-channel output, so it's going to be very fast. And again, the manufacturer controls the screening. Here's the actual interface. You'll see all these interfaces look pretty much the same. It would be important to select the correct media here. Okay? We have the separate rip and print resolutions that we had with the CT driver, but everything else is pretty much the same. And then you really have this one panel to print and measure to build your calibration file. So it's very, very fast, very, very easy to do. Okay? So those are all of our drivers. We have simple linearization, the CT, the wide format, and the RGB. Media selection is important for all of those. Control over the black channel for the CT, the wide format, and the HT, none for the black. Only control over the light inks and the lighting transitions with the HT driver. Relinearization is possible in all but the RGB. Optimization possible in all. And then we're building various types of output files, which does affect the speed. Okay. Where did these come into play? Well, the CT driver we recommend using for continuous tone proofing, which is what most of us are doing, or continuous tone production printing also. The HT really only if you're using specialty media. You really need to control the amount of ink. Okay, you really want to try to be able to control that cost, or if you are doing half-tone proofing. If you're printing 1-bit, those screened output files, you can get a little sharper dot if you use the half-tone driver. And the RGB, especially if you're printing photos, if you're bringing in RGB images, going to the RGB output device, it's fast, really good color. Okay? We see that driver used a lot at for instance, the office systems, the office printers that are set up to print RGB photos coming in. A lot of times they'll just stick with the RGB. Now the world is a little different with VUTEk Matan and Reggiani, and even if you don't have one of these printers, I want you to pay attention for the next few minutes here, because it's the same theory. You know, we're trying to do the per channel, the total ink limit, etc. There are some visual targets involved and some additional controls. Now, although you may not own a VUTEk, a Matan, or a Reggiani printer now, hey, maybe you buy one, maybe somebody is nice and gives you one for Christmas. But there's a chance that we might be switching some of the drivers for the newer printers that are not manufactured by EFI over to the same procedure, same process. So take a look here as we take a look at what happens with VUTEk Matan and Reggiani. Okay? I'm going to take my VUTEk printer here and say that I want to linearize it. Okay? Same, it copies everything, drops it into the linearization device, launches color tools, goes into the linearization device automatically. Let me go in and load my base linearization file here. Okay, and go to the settings. You'll see all of the same settings, really nothing different here. Okay, dot size, grayscale versus fixed. Am I going to use a variable droplet size? So we've got that little additional option here. And I've got the option to include gray balance and the quality control step. If you include the quality control step, you can compare your linearization file to your ICC reference profile like I showed you with the CT driver. If you don't include that, it's one less step you have to do. It's one less target you have to print and measure. However, you don't have the ability to compare the gamut then. Gray balance is especially important if you're printing expanded gamut printing where you have color management turned off and all you're using is the calibration file. You're not using ICC profiles. That means you can only print CMYK files, but it will use the entire gamut of the output device, sometimes called G7 Extreme for any of you that do G7 work. So including the gray balance is especially important in that step. Okay? Otherwise, some people say, well, the ICC profile does a perfectly adequate job. Others, boy, always want to use that gray balance. No harm really in doing that step. We click Next. And this interface now is going to look different. Here is where you are actively taking control, just like the HT driver, of your normal and light inks. How much light ink there is in the solid, where do I start my normal inks? Now, if you print this target and it comes out with too much ink, there's ink piling or some other issue, you can turn on this print with pre-ink limit, come in here and modify these. If I check this box, whatever I change will change to all of them. With this unchecked, I can check them individually. Okay? But this will modify the curves. It'll modify a little more than just that per channel total. So use caution going into that per channel ink limit. We do have a guide, a fairly extensive guide that covers all of these controls, and I do recommend you download that. We've got a link to that at the end of the presentation. But here I can have it set for automatic, or I can turn off automatic and modify how much light ink I have in my full tones, where I start my normal ink, okay? Even the curve adjustment, okay? How the curve shape changes. Now, there are two areas over here. One I want you to kind of ignore, and that's the ink consumption. The ink consumption could be important if you're only using normal inks, but if you're using normal and light, use a little caution, because this is the ink consumption to print this target, and it may really not have relation to the actual ink consumption. I have people say, oh, I'm going to lower these so I can get this ink consumption really low down, but then you really destroy your gamut. Please watch this area. The current gamut is the gamut of the output device based on the settings you've modified. This is the maximum gamut of the unmodified system. If you are doing high-end printing, try to keep the chroma within 1 to 1.5 of the maximum chroma. Okay, so as you can see here, I'm at 92.1. That's well within this gamut, so I'd be fine. If you're looking at really, really saving ink, you could drop down to 1.5, maybe even 2.5 away from chroma. But be cautious. If you lower this too much, you're just really going to destroy the potential gamut of your output device. Okay? We would then, once we have this set up, we would go to next, and then we print a visual target. The visual target looks like this. Let me move this out of the way for one moment. This is the visual target. It's a gradation of cyan, magenta, yellow, black, and the 2 color combinations, cyan and yellow, cyan and magenta, the 3 color combinations, and CMYK. And what you do to use this is you take a look, I've got a close-up here, and you look at where the hexagon first starts to be seen as differentiated from the outside area. Okay, now across here on my screen, I can see on all of these. On my 3 color over here, I can actually only see it here. So then you look at the corresponding color here, and the corresponding color gets dropped into the XF interface right here, for instance. Yellow, magenta. 200 is fine. You plug that in here. Err on the side of a little more ink. Now, you can go in between. I could say, well, boy, maybe I can convince myself I can see that, but I'm really not sure. So I'll go with 196. No harm in going somewhere in between. But you don't want to over-limit your inks. Now, if you're dealing with a Reggiani printer, it's a little different target. We've got these little wings coming out of little squares. And you're looking for these to be nice and crisply defined. You don't want to see these rounded or starting to fill in. But again, whatever you come up with, then you plug that value into the proper area of the interface and go from there. Okay? Here's our recommendation. Ideally, never touch the 200 or 300% values. Just leave them at the maximum. If you find that you're losing detail in those areas, then go back and lower the primary inks. Go back to that very first panel and undo that checkbox and check the checkbox at the top and go in and lower the individual inks. If for some reason or other you absolutely have to modify those colors, don't go below 190% on any of the 200 values or below 285 on any of the 300. We recommend you only adjust the 400% value, and again, never below 360. We find that it just causes more problems. If you find you have to go back and adjust those primary ink limits. Again, this is all covered in detail in that additional file that we're going to have for you to be able to drop down. Now, what happens if you do limit it too much? Well, here is the plot of 3 different profiles. The blue plot is the full ink profile or a linearization file. The red is dropped back a little. The green is dropped back 15%. So we've got 5 and 15%. And then I've got different L star or density values. 65, so the lighter areas, 40 all the way down to into the shadow areas. Now look at the shadow areas. Look how much color we lost here. Let's actually look at this on an ICC profile itself. Here is the profile with no ink limits, plotted in 3D color space. Now watch the top here, but especially watch this area down here, and then kind of the overall gamut as I click to the next slide. So watch closely. You'll notice the gamut looks like it didn't change. My whole top area didn't change. If I look at this profile from the top down, I say, hey, nothing happened. But look at these scoops. With 15% ink reduction, look at all the color I just threw away. If I take this area and look at kind of a side angle plot, all of this color in that area is now gone. There's nothing I can do to get it back in profiling. So use caution in reducing your ink. If you have a printer with white ink, we do recommend, well, there are two methods for linearizing the white ink. The first method is don't. Just leave it alone. What happens here is Fiery is going to generate a curve based on the other colors. The assumption is that, hey, the cyan, magenta, yellow, black inkjet heads are basically manufactured the same way as the white inkjet heads. So it's going to use the curves, the limits that it calculates for the other inks for the white ink. And we find for most people that works fine. If it doesn't for you, then you can build a custom white linearization. And what happens is if you select the white linearization file, or a printer with white in the name, this extra tab will show up. If you select a printer without white in the name, you won't have this tab. You won't have to print and measure the white ink, and XF will calculate it based on the other inks. But if you did select one with the white ink, you print and measure, and you'll get your curve. Now, normally, you won't need to adjust the normal ink. And because of that, it's grayed out. If you determine that it's just putting out too much white ink, go to the top of the panel, check the box, and go into the pre-ink limits, and you will see the white ink appear, and you can lower it here. Okay? So if needed, use the pre-ink limits. The recommendation is to leave the dot gain alone. That should give you a nice gradation curve, but you do have the option to adjust it. For most people, not it at all works. For the majority of the other people, simply measuring it and selecting the defaults works. For a very, very small minority, they find, well, yeah, they really do need to just modify that a little bit. So as you can see, we have a lot of tools. We've got some new tools for linearization for Matan, Reggiani, and VUTEk. These may be ported over to some of the newer printers from the other manufacturers. Otherwise, we've got the CT, the HT, and the RGB, and you can select whichever driver works best for your particular situations from the list that we have available. Kind of once you know the theory and the process behind it, you will be able to build a linearization file for any of our inkjet printers that we support, and that will be the basic fundamental situation, the best starting point you can have to build a high-quality ICC profile on top of it, which we'll cover in the next session, which will give you the best color you can get. Carrie, back to you.
Thank you, John, for that great insight into linearization. So some of the highlights of what we learned today are why custom linearizations are worth creating. They really are a key part of achieving superior color matches. They produce better gray balances, and they can, in fact, provide potential ink savings. We also learned about the different printer driver types and where they're best used, plus some do's and don'ts on ink limiting and ink reduction. If you'd like to learn more about linearization, we have some resources for you. We have 2 linearization guides, one for non-EFI printers and one for EFI printers. Both are available on help.efi.com. And as always, the presentation PDF that we send to you as a follow-up of the session contains live links to all web locations mentioned. So today's session was linearization in Fiery proServer and Fiery XF. As mentioned, we do have an additional session on profiling and optimization, which is happening on the 30th of November. And this session is now open for registration if you've not already done so. Also, we're currently in the process of defining the World of Fiery wide format calendar for next year, so why not tell us directly what you'd like to see us cover by completing the short Have Your Say form. And just a really quick reminder about the existing recorded World of Fiery wide format sessions from 2015 and 2016. Again, this presentation contains the live link.
All right, so we are over the top of the hour. There were a lot of great information that John shared about linearization, and we do look forward to completing the full topic with profiling in a few weeks. So hopefully many of you will be joining us for that at the end of November. We will be staying another 10 or so minutes to go over as many questions as we can through during that time. So we welcome you to stay with us to hear some of the questions. Obviously, we will compile an FAQ as we usually do and send that out with our follow-up email to you. But with that, Carrie, let's get a few questions in.
Okay, John, we have quite a few today, so quite a few interesting ones, so you never know, we might fox you here. So could you briefly touch on total ink limiting with regard to UV inks, as it's difficult to check for wetness since the inks are dry, more or less?
Right, well, there won't be wetness, but what you're looking for is ink piling. Actually, run your finger over it and see, is there an additional, is there just too much piling of ink that you're receiving? One of the other things is when you measure, if you find that FireXF is reducing the inks from the 100%, you know that it did measure where, okay, there's just too much ink there. So it did detect that there is too much ink. So it's a combination of that and actually physically just running your hand over it and seeing it, boy, there's raised areas here. This is just, more than what you would normally have on a UV ink laying on the surface. And that's really what your limits of being able to control the UV inks are.
Okay, great. And another question, occasionally on the quality control print, I get brown reversal in the 3-color scale. Reducing the ink limit seems to help. Any reason for this or any other fix?
Well, part of it is it's looking at the gray balance strip. I actually have that shown here in just a little bit. I think you're talking about, oh, no, not that one. One moment, please. Is this little guy here. It's very common that this is going to be lighter because it's kind of part of the ink savings feature that's sort of built into the calibration file where it's actually going to use black in these darker areas. So all you're looking here is to see that this is a nice even gradation, that every step is in a different color, yellow and blue and green and red and purple and orange, that it's a nice even gradation of color. And understand that black is going to come in here. This always looks a little funky here at the end. But the combination of using black then when the ICC profile comes into play seems to work just fine.
Okay, another question. If I have more than one Roland printer, how can I make those printers print out the same color?
That's going to be part of the profiling, not part of the calibration. We hear that a lot. People say, well, how do I calibrate this machine to match that machine? You don't. The idea behind calibration or linearization is to give you the best results possible from that output device. Then we can use ICC profiles or the optimization process to try to match the capability of one printer to the other printer. So I will be covering that in the next session. So there's a reason to come back in November.
Thank you. Next question, are you able to apply a G7 curve with or without color management turned on, meaning full gamut or limited to a simulation space?
Yes, what you would do is you would build a G7 curve and you would build a linearization file, just like we showed today. You would load that, and then on the panel, on the media panel of the output device, right here, you could select that G7 curve. So you build it as a VCC curve or a visual correction curve. And then you can load it here, and as long as you have your linearization file in place with color management turned off, you will use that G7 curve and the calibration file to give you a gray balanced output device using the full gamut of the output device. And that is, there are 2 documents in help.efi.com that cover this in detail and give you step-by-step how to do it.
Okay, and one on dot gain. Should dot gain be 40 or 50?
Yes. 40 or 50 is just where it's calculated. In different parts of the world, it's calculated at the 40% step. At others, it's calculated at the 50%. Negligible difference. Nothing that's ever going to cause problems. We just kind of put it in there because people in different parts of the world are used to looking at dot gain. But since I recommend not modifying it anyway, no matter what, I played around with trying to improve the gray balance using that. I have found it a complete waste of time. So it doesn't matter because it's not going to make any difference to you.
Okay, great. And where do you set the M0, M2, and M3 filter on a Barbieri device in the settings for the main linearization?
If you select your Barbieri device and if it's software controlled, then in the settings file there should be a drop-down menu for the illuminance. And that goes for any of our supported devices where we can control the illuminant from the device is on that drop-down list on that very, very first panel.
Okay, and how often should I linearize?
Great question. Well, like any answer to the world of color management, I always say it's the same one, and the answer is, well, that depends. How good does the color have to be? How small do you want those delta E values? To be honest, our output devices are very, very stable these days. You would certainly want to linearize, start the process with any new media, new brand of media, not necessarily the next roll of media from the same batch. But anytime you see a box of media or a box of ink come in that has a sticker on it that says new and improved, your life has just ceased to be fun because you're going to have to do probably a recalibration, reoptimization on when you start using that new media or new ink. But barring that, I do recommend you use something, you really monitor it. That's going to be the best, you can do it the poor man's approach, print out some pretty pictures when you finish the calibration and profiling. Put that in a dark area, away from things that are going to modify the output, especially on aqueous inkjet. You want it kind of in a darker place. But then print that out every Monday and compare it in a light booth. Hey, how does it look? The best way would be to use the verification module in Fiery proServer and an add-on in Fiery XF and actually measure color bars and use relinearization or reoptimization as a quality control tool, not a, oh, it's broken, I've got to fix it, where we're now out of control. But you'll watch and you'll see that the delta E values start rising, then you would relinearize or reoptimize. So if you're doing high-end proofing where you live and die by what the numbers are, you should already be using verification of some sort, monitor the system, and when the numbers start to get a little high, do it as preventative maintenance. If you don't have the verification module, hey, go buy it. It's not that expensive. But otherwise, use a set of sample images and just visually detect when you feel, hey, you know, yeah, I'm seeing some color differences here. I'm going to redo my system.
Okay, so you just answered the next question, which is great as well. So how do we get a good gray balance? Ours always seems to have a cast, usually in the lighter areas.
Well, an ICC profile should take care of that. If you see a cast in the lighter areas and you build a custom calibration file and a custom ICC profile, likely it's an issue with UV brighteners in the media. Might be an incorrect setting on your measurement device. It might be that the lighting that you're using to evaluate the image is not, well, effectively M1. It's not uncommon that someone will take an output and look at it under standard room lighting. Well, that may not have the right amount of UV light component that matches the amount of UV light that the spectrophotometer expected to see. So that's probably the most common thing that I see. An option then would be to build a G7 curve, or maybe just add a visual curve if you don't have the tools to build a G7 curve. Just add a visual adjustment curve and add a little bump curve in the highlight areas to offset the color that you're seeing. Sometimes optimization can help improve the gray balance, but usually it's a lighting, UV brightener, spectrophotometer compatibility issue.
So I think we're going to take one more question, Carrie, and anything we didn't cover we'll make sure to get back individually to folks, and of course have a complete FAQ for everyone. So one more.
Okay, John. So for fine art reproduction using RGB scans as TIFF files dropped into the RIP, would you recommend the RGB or CT driver for the best match on the photo in the photo and artwork world?
Well, the photo and artwork world, you're usually looking at something like ProPhoto or Adobe RGB as the reference profile. And I do find a lot of times with the RGB, I get a little more gamut out of the output device. The assumption kind of is that if you're using the CT or the HT driver, that we're more into the proofing production world where, hey, maybe we have to have the banner, the poster, the billboard match existing printed pieces. So sometimes that gamut is a little more limited with the CT and HT drivers from the manufacturer. Boy, RGB tends to sometimes be the most wide open. There's less control you have. You can't do recalibration. You can do optimization, but you cannot optimize to an RGB color space for the most part. If you try to do an optimization, please bear in mind it's going to optimize to the CMYK space until you really, there are different ways where you can really force the RGB profile down its little throat and make sure it does that. But in most cases, the RGB color space is still larger than your inkjet color space. And it's just going to say, hey, the delta E values are too high right on the very first step, and there's nothing I can do about it. So you have a little less control over, let's say, the world of proofing color accuracy, but if you're in the fine art world, that really shouldn't be an issue. And I really would have no problem doing the RGB driver. Repeatability, if you know your customers are going to come back and say, I need this reprinted, a year from now, and it's got to match what you printed today, then I would recommend you go more towards the CT driver because then you've got more options for optimizing to make sure the color is accurate over time. So if you don't have to worry about color repeatability and it's just, hey, as much gamut as I can get, yeah, the RGB driver is pretty much a good choice and runs faster. But if repeatability is an issue, I'd lean towards the CT driver.
Thank you, John.
All right.
You're welcome.
Thank you. So we got a number of questions in. I know that there are more. As we said, we'll get back to you personally and then have an FAQ. A copy of the presentation will also be made available, as well as a link to the recording so you can listen again or share with anyone who missed our presentation today. So with that, I want to thank our audience. Thank you for hanging with us over time. John and Carrie, great job. Thank you very much. And we do hope everybody joins us in November, where we wrap up the larger topic of linearization and optimization. We'll have a great session for you, more information coming, but you can already go online and register on our website for that November 30th session. Looking forward to that. Have a great day, everyone, and thanks again.